Hi, welcome to this lesson on Analytical Geometry, Circles Part 2. Let's have a look at question 3. A circle with center N 4, 4 passes through the points K 1, 6 and L 6, 7. Determine the equation of the circle. Okay, so roughly these are the 3 points we have here, and this is the center point. So essentially we have a circle that passes through those points. Okay, so hypothetically this is what the circle would look like. Right, and from K to N and N to L, these are both the radius lengths. Okay, so first of all, the equation of the circle with that center, remember, it's given by, so the opposite of positive 4 is negative 4, so x minus 4 all squared plus, and again, the opposite of positive 4 is negative 4 all squared, and that's equal to r squared. So we just need the value of the radius r, and then we've got the full equation of the circle. Okay, so to work that out, I'm just going to find the distance between K and N. That would be the same as the distance between L and N as well. So either one of these triangles, right angle triangles, you can find the hypotenuse length for, and it should be the same. So let's validate that and do both so we can check. So again, so here's the point N, here's the point K. So from 1 to 4, that's 3 units horizontally, and from 4 to 6, that's 2 units vertically up. So therefore, I would have 2 squared plus 3 squared equals this radius r squared. So 2 squared is 4, 3 squared is 9. So therefore, r squared is equal to 13. And we just needed the value of r squared. Okay, so essentially, this is going to be equal to 13. And that is the equation of the circle that's given here. And if we wanted to use the other triangle, where N here is the point 4, 4 and L is the point 6, 7. Again, from 4 to 6 is 2 units horizontally, and from 4 up to 7 is 3 units up vertically. So again, if I use the Pythagorean theorem, it's going to be 3 squared plus 2 squared equals r squared, which will still give you 13. Okay, so that is the equation of the circle with that center. Next, we want to determine the coordinates of M, the midpoint of KL. So if you draw a line KL here, we want the midpoint here. Okay, so again, how do I find the midpoint? I can use the midpoint formula. So the midpoint is equal to the sum of the x coordinates, xk and xl, divided by 2, and the sum of the y coordinates divided by 2. So that's going to equal to xk is 1 and xl is 6 divided by 2, and then the y of k is 6 and the y of l is 7 divided by 2. So 1 plus 6 is 7 divided by 2, and 6 plus 7 is 13 over 2. Okay, and that's the coordinate. If you want to write it in its decimal form, that's going to be 3.5, so 3.5, right? And then forward says that's going to be 6.5, 6.5. Okay, so that is the coordinates of the midpoint of the line KL. Next, we want to show that MN is perpendicular to KL. So remember, M here was the midpoint, M, and we want to draw this line MN, and we want to show that this is perpendicular. Okay, now automatically, if you think about this from a circle geometrical standpoint, remember, because there's a circle that's going through here somehow, right? And think about this, KL essentially is a chord on the circle, and N is the center of the circle. And we know that if you are going to take a line going from the center to a chord such that it bisects the chord, so it cuts it in half, then that is perpendicular to that chord. That is one of the circle geometry theorems we've learned. So there's one of two ways we can prove this, from a circle geometrical point or from an algebraic point. So what do I mean by algebraic point? Well, from an algebraic point is if I can work out the gradients of those two lines and show that the product is -1, then that also shows that these two lines are perpendicular. So that's awesome, because there are two different ways we can go ahead and prove this. So let's go ahead and prove it the first way, using the circle geometry theorem ways that we know. Okay, so what we're going to say, so proof. Okay, so we can say KL is a chord of circle N. Okay, so the circle N is the one that has center N, all right? Circle N, where N is the center, okay? So what we have is the line MN is a line from the center to the chord KL such that KM is equal to ML. And how do we know that? Is because M is the midpoint. The midpoint of KL. We've just we just found the value of M in the last question. Okay, so hence we can say that the chord KL is perpendicular to the line MN, and the reason for that, the theorem is line from center to midpoint of chord is perpendicular. Okay, so the theorem we are using is line from center to midpoint of a chord cuts that chord at a perpendicular angle. All right, what is the second way we can do it? Well, if I work out the gradient of the line KL, okay, I can do that, right, using rise over run. So it goes up by 1 unit and it goes across by 5 units. So the gradient is 1 over 5. And the gradient of the line MN, so remember M again was the points, let's just go up here again, 3.5 and 6.5. Okay, so again, if I do rise over run, you can see it's going to be a negative gradient because the line is decreasing from left to right, so it's going to be negative gradient. So the y value is from 6.5 to 4, that's 1.5 in length, right? No, not 1.5, let's just check. So I'm looking at the vertical heights, okay, from 6.5 to 4. Yes, it's 1.5, right? Because 4 plus 1.5, no, sorry, it should be 2.5. There we go. 4 plus 2.5 is 6.5. Okay, so it's 2.5 units vertically. And then from 4 to 3.5, that's a half, 0.5 units. So it's negative 2.5, which I can write as 5 over 2, divided by a half. That's rise over run here. So when I divide by a fraction, I multiply by the reciprocal, which is 2 over 1. So I'm going to have those divide in, and I'm left with negative 5. So therefore, the product of these two gradients is going to be 1/5 times negative 5, which is negative 1. And because we have that, we can conclude, therefore, that the two lines are perpendicular. Okay, so that's great because there are two different ways we can prove that those two lines are perpendicular. Awesome. If P is a point on the circle such that LP is a diameter, determine the coordinates of P. Okay, so again, a very good question, right? So again, we've got some sort of circle that's probably looking something like this. Okay, it's a very rough diagram. It might even cut through the x-axis. We don't know yet. Or we can if we just substitute some points in. But for now, what I'm interested in doing is analyzing the symmetry of the points. So here's the point L, and we want it to be a diameter. So if I go through the radius through in here, I must go the radius amount through here as well. So there will be the point P. And again, N is the midpoint. It's the center of the diameter. So what happens is, so to go from 7 to 4, I went 3 down. And then from 6 to 4, I went 2 across. So I must preserve that same proportion. So going down from 4, 3 down, and then going 4, 2 across, that gives you the point. So that'll give you the point 2, 1. Okay, so the point P is given by the point 2, 1. And again, that comes from the symmetry argument. Okay, the symmetrical argument for a point on the circle going through the center to find the opposite point that would make it a diameter. Okay, and then determine the equation of the line LP. So again, P was given here. It was given by the point 2, 1. All right. So again, if I want the equation of this line, I need the gradient. Okay, so again, from 7 to 1, I've moved down 6, and from 6 to 2, I've moved down 4. So my gradient of the line LP is going to be positive 6 over 4 because it's a positive gradient, which is 3 over 2. So I got my form y equals 3 over 2x plus c. And then I substitute a point. Can be any of the 3 points on that straight line. I'm just going to substitute the point L6, 7. So I'm going to have 7 equals 3 over 2 times 6 plus c. But 2 goes into 6 3 times, so that's 9 plus c equals 7. So therefore, c is equal to negative 2. So therefore the equation of the line LP is given by 3 over 2x minus 2. Okay, and that is the equation of that diameter line. Awesome. I'll see you in the next one.